Put the heading as common acceleration of the system. Common acceleration. I'll directly start with some questions. It's very, very important to understand. One, two, and three. Find T1, T2, A, F net on each mass. Net force on each mass they are asking you. Okay. Now how to do this question? Please pay attention. See, if the tension is the same, the acceleration will also be the same. What do you mean by this? If there is one string, the tension will remain the same in this string. If the string will change, the tension will also change. This is 1 kg, this is 2 kg, and this is 3 kg. We are assuming, I'll assume that the acceleration of the whole system is up. So this part is going up. This part of the system will come down with acceleration A. Yes or no, beta? Okay. I'll assume that this string is having tension T1. You know the direction of tension is away from the body. This part of the string is also having tension T1. And this is different string. So we'll have different tension. Follow, dekh lo. Okay. How much is the force acting downwards of this body? 1 kg. So can I say it is 10 Newton? How much is this beta? And how much is this beta? 30 Newton. Correct or wrong? Correct, no? Can you see? Now I need A, I need T1, I need T2, I need F net. A ka formula. Acceleration is defined as net pulling force upon total mass. What is the formula for common acceleration of the system? Net pulling force upon total mass. Don't write, listen first. Net pulling force. See, over here he is pulling with 30 and 20. So this side it is pulling with 50 and that side is pulling with what? 10. So how much is the net force? If you try to make the string straight, over here beta is 50 and over here how much it is? 10. So how much is the net pulling force? It will become 30 plus 20, that will become 50 minus 10 by total mass. Total mass is 3, 4, 5 and 6. So it will become 40 by 6. So acceleration is going to become 20 by 3 meter per second square. And this is the formula for common acceleration of the system. समझ में आई बात? Okay. This is pulling down with 10. This is pulling down with 50. So how much is the net? Net will go that way, na? This system will go this way. So acceleration will become 20 by 3 meter per second square. Got it? Now to find T1 and T2, I will draw free body diagram of 1 and 3. Okay, how to draw free body diagram of 1? Look over here. I will take 1 kg. What is acting down, beta? 10 Newton. What is acting up? T1. Where is the system going, beta? Up. I'll apply F net is MA. F net is MA. What is F net? F net will become big force minus small force because the whole system is going up, na? So who is big? T1. minus 10 will become ma. What is a? What is 1 into a? So will become T1 will become 10 plus a. What is a? So T1 is going to become 50 by 3 Newton. Bolo, correct? Now I'll draw free body diagram of beta 3. You can draw it with 2 also. I'll show it to you later. 3. So 3 kg. Who's acting down? 30. Who's acting up? T2. Where is the system going? Down. Can I apply F net is MA? How much is F net? 30 minus T2. How much is M? 3. What is A? 20 by 3. So T2 will become 30 minus 20. It will become T2 will become what? 10 Newton. Yes or no? Everyone, yes or no? Now I need F net on each mass. What is the formula for F net? Can I say F net on 1 kg will become 1 into A? What is F net on 2 kg? 2 into A. What is F net on 3 kg? 3 into A. अरे भाई ठीक है ना? Thus you can find out. देख लो. Suppose I need to find free body diagram of 2 kg. We have got all the things. Suppose you need to find free body diagram of 2 kg. तो कैसे करना है? ये 2 को देखो नीचे कौन है? T2 और उसका वेट खुद का ऊपर कौन है? T1. And where is the whole system accelerating? Down. Now you can apply F net is MA. बोलो F net is MA. F net कौन है? T2 plus 20 minus T1. M कितना है बेटा? 2. और A कितना है बेटा? You can solve for, यहां से आपको देखो T1 तो ये है ना, T1 यहां से you put it here, you get the value of T2 and the same T2 will come as how many Newton? 10 Newton. Did you understand? So the whole masses, I have just opened everything. When the mass as a whole system we were considering, T1, T2 was cancelling because they are internal forces. When I break 3, break 2, break 1 out of the system, you can see T1, T2. Got it? Everyone, start. Question 1, 2, 4 and 6 mass on an inclined plane 30 and 30. Find acceleration of the whole system. Tension 1, 2 and 3 and F net on each mass. Okay? I'll assume this system to go this way. The 6 kg is going down. I'm assuming. It's going down. It's going up. This is also going up. Right? If your assumption is wrong, you will get negative answer. Okay, beta? Now, please tell me how much of the weight. This weight is how much? 10 Newton. Listen, huh? How much will be iska mass acting down? You know, on an inclined plane, the weight acting downwards is mg sin theta. This is the weight, na beta, mg. This component will become what? Mg sin theta. And who will balance the normal reaction? Mg cos theta. This I told you before also. So how much will be mg sin theta over here? Mg कितना रहेगा बेटा? 20. Sin 30 कितना होता है? So 20 का half will become what? 10 Newton down. Always remember mg sin theta. And इसका कितना रहेगा? mg is 40. Sin 30 half will become what? 20 Newton. Correct है ना? अच्छा, can anyone tell me how many strings are there? What is this? Three different strings are there. 1, 2, 3. So how many tensions will be there? 3. Look. T1, T1, 2, 2, 3, 3. Correct? Can you see it? Yes or no? Now I need acceleration. General formula for acceleration is what? We have done it. Net pulling force upon total mass. How much is the net pulling force? You in your imagination try to make the string straight. This part is 60 plus 20. 60 plus 20, 80. This part is 10 plus 10, 20. So net pulling force this side is correct, will become 60 plus 20 this side minus 10 plus 10 that side upon total mass of the system. 6, 10, 12, 13. Listen over here. So it will become 80 minus 20 is 60 by 13 meter per second square. Correct? Got it, no? Now I need T1. For getting T1, I'll break this. How much of that? 1 kg. 10 Newton. T1. A up. Apply net force is MA. Come on. Come on, apply fast. What? Yeah. Net force is MA. Net force क्या रहेगा? T1 minus 10 is M. What is M? 1. And what is A? 60 by 13. You will get the value of T1 whatever Newton comes. Getting it? Next one. T3 के लिए I'll take this. This is what? 6 kg. ऊपर is what? T3. Down is what? 60. And who is the where is the acceleration? Down will become net force is MA. Net force क्या रहेगा? 60 minus T3 is M, that is 6 into A is 60 by 13. You get T3 as that much Newton. Okay. For getting T2, I'll break this. So look now. This is 2. T2 is this way. T1 is down. Plus who is acting with T1? 10. And where is the acceleration of the system? This way. Now this will become my axis. Initially you were considering this as your y and this is your x axis, right? Now this is your x axis and this is your y axis. You understanding? So I'll apply net force or Newton formula along this line. What will become? Where's the system going up? So I'll apply net force as MA. Net force will become what? Come on. T2 minus T1 plus 10. 2 into A. What is A? 60 by 13. Over here you will get what? T2, because T1 you can substitute from here. Got it? If you don't want this free body diagram, you can draw free body diagram of 4 also. We'll see how. It's 4. Who is acting down? T3 plus 20. Who's acting up? T2. Where is the acceleration of the system? Down. Can I say net force is MA? Come on, net force is MA. Fast. Come on, man. T3 plus 20 minus T2 is equal to MA. What do I get? That's what Newton. So how much is F net? F net on each mass. F net on 1 kg will become 1 into A, na? What are they? F net on 2. 2 into 60 by 13. F net on 4. 4 into 60 by 13. F net on 6. 6 into 60 by 13. Got it? So this is the whole question which is asked in the examination. They will not ask you everything. They can ask you a part of it. Easy level question, they will ask you only A. Difficult level question, they can ask you T1, T2 and T3. Okay? And if more difficult, they will add friction also. Initially all the surfaces right now are smooth. The next part, we will add friction. We will do the same sums but with friction over there. So we have to see what is the relative motion. Got it? Start. These are some questions based on normal reactions. How it is, we'll see. System of blocks. 21 Newton is the push. From here it is 7 Newton. So can I say the net acceleration of the system will be taken this way? Yes or no? They are telling you to find what is A, what is N1, what is N2, okay, and what is the net force on each block. We'll see how it is. Okay. सबसे पहले A का फॉर्मूला क्या है? Net pulling force or pushing force upon total mass ना? Because force is a push or a pull. तो यहाँ पर there is no pulling, there is pushing. Pushing, no problem with that. Or net force upon total mass. Net force, how much is the net force? Over here is 21. Over here it is 7. Become 21 minus 7. 7. Correct? Correct. Now I need their normal reactions. They are touching. In between them there will be normal reaction. Let the normal reaction be named as N1. N2, correct na? Yes or no beta? So what is the direction of normal reaction? Towards the body. Perpendicular to the surface and towards the body. Now if I draw free body diagram of 4. 21. N1. Where's he? Can you apply F net in में? F net कितना है? 21 minus N1. M कितना है? 4. A कितना है? 2. Yes or no? Come to 1 kg. यहाँ से कितना बेटा? 7. यहाँ से कितना रहेगा? N2. The system is accelerating this way. F net कितना रहेगा? N2 minus 7. Big minus small. Correct. अच्छा F net चाहिए. F net on 4. MA. Clear? अच्छा suppose you tell me draw free body diagram of 2 kg sir. ये 2. इधर से कौन आएगा? करेक्ट सर. कौन बड़ा? करेंगे ना? First point, if the string is not massless, usually tension is not uniform. Tension is not uniform. not uniform. Next point, to find tension in the rope. To find tension in the rope, find common acceleration. And apply F net is MA. And apply F net is MA at that respective point. At that respective point. Okay. Shh, listen. I want to find common acceleration of the system. Tension at A, tension at B, tension at C. Tension at A, tension at B, tension at C. The ABC a point, and the rope is not massless. The rope is having a mass of 4 kg. So we know that at every point tension will be different. How? We'll see. First I'll find out common acceleration of the system. Now you know that this is 2, this is 4 and this is 2. The weight as a whole total will be how much? 80 Newton down. 6 and 8, 80 na? Down. Upar se I am pulling it with what? How many Newtons? 72. But where will be the common acceleration of the system? Down. You know, because this force is more than this. Common acceleration and net pulling force upon total mass. Net pulling force will become 80 minus 72 by how much is the mass? 4, 5, 6, 7, 8. 1 meter per second square. Where? Downwards. Look now. Now, to find tension at A, cut the rope at A. Cut the rope at A. This much. So how will be the free body diagram of this? It's 2 kg. 72 up. Where's the direction of tension? Body away, na? Body away. And where will be the resultant acceleration of the system? Down. Can I apply net forces MA? Net force will be what? TA minus 72 is 2 into A. A is given as 1. Right or not? M is 2 into A, correct? Everyone has understanding. We have missed one thing, sorry. We have missed the 20 weight, na? His weight is what? 20. So it will become TA plus 20. Correct, na? So this will become what? 54. Got it? We have missed the weight. We come to TB. To find tension at B, cut the rope at B. Cut the rope at B. It's 2 kg. What is acting down better? What is acting up? TB. Because tension is away from the body. Body away. There's net force. MA. What is net force better? 20 minus TB is 2. Into A is what? 1. So TB will become what? Again what? 18. Look again. 20 TBA. So it will become 20 minus TB is MA. Getting it now? Now to find TC, cut the rope at C. Pay attention to this, huh? This is the most important thing. If I cut the rope at C, it will become how? See, this is 2. This is the rope, right? The C is in the middle. They are telling you that C is in the middle. Since it is there in the middle, the 4 kg will be divided into 2 kg up and 2 kg down. So how much is the mass of this 2 kg? And where will be the direction of TC? Away from the body? Bolo. Where the weight acting? How much is the weight? How much? Don't write 20. It will become what? 40. 2 will become 40 Newton. And where will the acceleration of the system be? Down, right? F net is MA. What is F net? 40 minus TC. 40 minus TC is equal to MA. What is M? What is M? Total mass. How much is the total mass? 4. Don't write 2, huh? 4. What is A? 1. So TC will become what? 36 Newton. Now if you see, the tension at A was 54. C is 36. B is 18. Means as I go down, the tension becomes lesser and lesser. You know why? You know why? Because this part is holding this part as well as this part. So the tension will be more. This part of the string C is holding this part and this part only. Tension will become comparatively lesser than B. A. This part is only holding what? 2. Understand? So this part will be having comparatively less tension than all the other parts which are above. Got it? Fine. Put the heading as constraint equations. Constraint equations. Constraint equations. Okay. Constraint equations, huh? Example 1. Just start with the example so that you can understand. Pera lesson over here. I want to find the relations between the accelerations. इधर ध्यान देना, सब लोग को समझेगा नहीं वरना. हमने क्या assume किया था previous questions में that this is going up with A and this is coming down with A. याद है ना? Now I'll take a relation that this is going up with A1 and this is coming down with A2. And I'm proving that A1 is equal to A2 is equal to A. Okay, you could have asked me the question in the previous thing that, sir, why this is A and why this is A down? Why both the A's are the same? Okay. Why both the A's are the same? Cannot the A's differ? Can this be A1 and this be A2? We'll see over here. I'll prove over here that A1 is equal to A2. What about tension in the string? Come on, tell me. This tension will become T. You know, na, tension is away from the body. Correct? There are 2 methods. Actually, there are 3 methods. I am skipping the 3rd method. I am doing 2 methods with you all. Method 1. Always remember, summation of T bar dot A bar is 0. T T bar dot A bar is 0. Work done by the string is 0. Second method is T is inverse to acceleration. T is inverse to acceleration. How this is, we'll see. Because the string length will remain constant, na beta. So how much is the work done by the string along the length? 0. Because there is no displacement, na? Is the string getting extended? No, it is an inextensible string. So total work done by the string, that is T bar dot A bar, where what is A? Acceleration, has to be 0. ठीक है, देखते हैं हम लोग, we'll understand. इधर ध्यान दीजिए बेटा, इसका टी ए निकालो. कैन आई से इट बी टी A1 cos 0? सेम डायरेक्शन ना? अरे सेम डायरेक्शन और नॉट. दूसरा वाला क्या रहेगा बेटा, इसका देखो, बोलो. टी A2 cos 180 has to be 0. अरे बाबा, they are in opposite direction. He's going down with A, he's going up with A. तो क्या हो जाएगा, TA1 minus TA2 is equal to 0. So TA1 is equal to TA2. So A1 will become equal to A2 is a common name A. Okay na? Okay. This will, you will tell me, sir, this is the easy sum. I'll do some other sums where you will understand. Asha, second method is also there. Tension is inverse to acceleration. Can I say tension is the same? So acceleration in both the systems will also be the same. So if T1 is equal to T2, then A1 will become equal to A2. Got it? Now we'll see another sum. So the easy. Tell me, sir, how to do this sum. I am developing relations between acceleration. Look. Okay. Now, just pay attention over here. See now, listen over here. How to develop? What happened? Some doubt.
How do you get?
What is the formula for work done? Force is tension. Take double derivative of displacement. ठीक है? So t into s is 0. T into double derivative of s will also be 0. बात समझ आई? Pay attention over here. Listen. Here. Now this system is going down. You can see if this goes here with A1. This mass goes down with A2. You don't know the relation. You cannot say it is common acceleration. Why? Because tension in both the strings is not the same. How, sir? How? Suppose, listen beta. Suppose इसका tension is T. बोलो. So how much will be tension in this string? 2T. See na? 2T. Baba, this is T and this is T. So to remain in equilibrium, this has to be what? 2T. देखो. Are you understanding? This has to remain 2T. अच्छा, method 1 says T is inverse to area. Acceleration. If the tension of him is double, then his acceleration will become half. तो अगर इसका acceleration you are taking beta A, so his acceleration will take how much? A by 2. बात समझ आई? इसी से क्वेश्चन अभी शुरू होता है. देन ओनली यू विल ड्रॉ फ्री बॉडी डायग्राम ना, एंड यू विल राइट एफ नेट इज एम ए, बट इसका ए आप कितना लेंगे, अदरवाइज इफ यू टेक ए 0. बात समझ में आ रही है आपको? सेकेंड मेथड क्या कह रहा है? सेकेंड मेथड यू नो टी इंटू ए. मेथड 2 क्या है बेटा? समेशन ऑफ टी बार डॉट ए बार 0 ना, तो टी ए कॉस 0 एंड 2t. देखो इधर t डॉट ए और a1 एंड इसका क्या रहेगा, 2t ऊपर है ना बेटा एंड a2 नीचे है, तो विल बिकम 2t इंटू a2 विल बिकम 0. अरे देखो, सो a2 क्या हो जाएगा, तो a2 is a1 by 2 ना. Any method you can fit. There is a third method also. You take double differentiate. Actual method you will get that. But I don't want to do. You just remember the method how to calculate the acceleration of the systems. Got it? अभी मैं आपसे कहूँ इसका फ्री बॉडी डायग्राम बनाओ. चलो बनाओ. Anyone? FBD of 2. I'm not doing it. Orally you do, please. नीचे कौन है? अरे नीचे कौन है? F net दे में ना. नीचे कौन है? 20 है. ऊपर कौन है? 2t. इस m में m कितना है? 2. a कितना है? इक्वेशन 1. FBD of whom? 2 kg ना. yes or no? अच्छा FBD of 1 kg बनाओ. बनाओ. F net दे में एफ नेट कितना है? टी है और कोई है नहीं. अरे डोंट लुक अप एंड डाउन, इज नॉट डिस्प्लेसिंग अप एंड डाउन. एक्सेलरेशन इस तरफ है तो इस तरफ इक्वेशन लिखना है. सो हु इज एफ नेट? टी इज इक्वल टू व्हाट? एम ए. बट एम कितना है? 1. ए कितना है? ए. सॉल्व देम साइमल्टेनियसली. देखो टी एन ए सॉल्व. यू गेट द आंसर ऑफ टी एन ए. बोलो. दैट व्हाटएवर आंसर कम्स यू नॉट बॉदर्ड. यू गॉट दिस थिंग. This kind of sum. सबसे पहले we'll do with the tensions. I'll take this tension as T. This will also be T. So beta this will be how much? देखो T और T नीचे है तो it will become 2T. सही है? सही है ना? We'll assume this going down and this going up. तो अगर इसका टेंशन T है और इसका टेंशन इससे डबल है तो if his acceleration beta is how much? A, then his acceleration will become what? A by 2. Tension is double, so acceleration will be half. Now I told you T is inverse to A. Yes or no? अच्छा इसका फ्री बॉडी डायग्राम लिखना है तो come on. FBD of 2. बोलो. नीचे कौन है? 20 नीचे. ऊपर कौन? T is MA. 2 and 2 A. इक्वेशन 1 करेक्ट. FBD of 1 लिखना है तो बताओ. नीचे कौन है? 10. ऊपर कौन है? 2t. सो F net है में तो ऊपर का फोर्स ज्यादा हैवी है ना, बिकॉज दिस गोइंग अप. सो 2t minus 10 is equal to 1 into A by 2. Solve them, you get the value of T and A by 2 or A. Got it? Start. Start from here. As a hint, start from here. T. देख लो ना, करेक्ट है। इसको मैंने एज्यूम किया A1 से ऊपर जाते हुए एंड उसको नीचे जाते हुए विद A2। नाउ लिसन, प्लीज पे अटेंशन ओवर हियर। इधर यहां से शुरू किया मैंने T, सो T तो ये हो जाएगा 2T, 2T and 2T will become 4T, 4T and 4T will become 8T. This is not required, I've just written over here because the ceiling is not moving. What is the total tension acting on 1 kg? 70। देखिए 4T, 2T and T, कितना टेंशन है? 70। So this A, अगर इसको आपने A लिया, so this will become what? A/7। बोलो, अगर इसका टेंशन इससे 60 टाइम्स ज्यादा है, सो इसका एक्सेलरेशन विल बिकम A/7, करेक्ट? टेल मी मैन। नाउ यू राइट फ्री बॉडी डायग्राम ऑफ 1 kg। बोलो फ्री बॉडी डायग्राम ऑफ 1 kg कैसा रहेगा? 1 kg ऊपर कितना T है? 70 है ना, नीचे कौन है? 10, and this acceleration will become A/7। Can I say F net is ma? F net कितना है? 10 minus 70 is equal to m is 1 into A/7, इक्वेशन नंबर 1। अब 2 kg का इक्वेशन लिखिए, 2, ऊपर कौन है? T, नीचे कौन है? 20 न्यूटन। And where's the system going up with A? It will become T minus 20 is equal to 2A. Solve 1 and 2, you will get the value of A and T. Okay?